Hello student, this is Rashekar. Welcome to SS Learning Academy. So now I'm going to teaching you what is meant by random variable and probability distribution. So before going to the this topic, let's see some of the definitions which we have necessary in the coming topic. One, the first one, what is meant by trial and event? Trial is nothing but the experiment is called trial and the outcome of an experiment is called event. For example, I'm tossing a coin, I'm doing that experiment, right? So that experiment is called trial. Getting head or tail is called event. Okay, so let's repeat again. What is mean by trial and event? The experiment is called trial and the outcome of an experiment is called event. Okay, right. So for that we seen an example, tossing a coin. I'm doing that experiment, right? So which will be called as trial, and the result of the experiment, I mean when I'm tossing a coin, will get head or tail. That head or tail will call it as event. Okay, right. So now let's go to the second example. What is mean by sample space? The total number of events arranged in a set is known as sample space and it is denoted by S. Like we'll see example. Suppose see just now we tossed a coin, right? So by tossing a coin, what are the outcomes? I'll get i'll get head, yes or no? I'll get head or I'll get tail. So these two possible outcomes I'm keeping in a set. Then this set is called sample space. This set is called sample space. See, let's see again. The total number of events arranged in a set is known as sample space and it is denoted by yes. See, in this example, I tossed a coin, right? Suppose I'm tossing two coins. Then what are the possible outcomes? Tell me. Head, 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 tail, tail, head, and tail, tail, right? See, these are the possible outcomes and these outcomes I'm keeping in a set. Then this set is called sample space. Okay, collection of all outcomes keeping in a set is called sample space. Okay, right. So we'll go to the next example, that is random variable. Okay, just a minute. Right. So what is mean by random variable? A real variable capital X whose values is determined by the outcome of an experiment is called a random variable. Let's say again, a real variable capital X whose values is determined by the outcome of an random experiment is called a random variable, which can also say in the different words, a real valued function having a domain as a sample space associated with a random experiment, which is also called a random variable. For example, let's say, so before I think I took the example tossing a coin, right? Let's take the same example. I'm tossing a coin. So what are the possible outcomes? Hmm? Head and tail. These are the possible outcomes, right? Right. See, these possible outcomes I'm keeping in a set, and we know this is also called sample space. Yes, right? Yes. So what is mean by random variable? I'm taking a random variable. There are 0, 1, okay, 1, 2, 3, which is associated with a real number, right? What is mean by x here? X is not a variable. X is a real variable. X is a real variable, right? What is mean by x here? My x is nothing but getting getting number of heads. See how many heads I'm getting in this experiment. Getting one head, right? See, so this head is associated with a 1. So it is nothing but there is a mapping from sample space to real number, right? So this is called random variable. Let's say again, a real value variable capital X whose values is determined by the outcome of a random experiment is called random variable. Okay, is it clear? I think, yeah. So we'll go to further. So these random variables are two types. Let's see, random variables are two types. One is discrete random variable and one more continuous random variable. So what is mean by the discrete random variable? A random variable capital X which can take only finite number of discrete values in the interval of domain is called a discrete random variable. In other words, if it random variable takes the values only on the set 0, 1, 2, so on n is called a discrete random variable. I think everyone is understand. A random variable capital X which can take only a finite number of discrete values in an interval of domain is called discrete random variable. Right, I'm tossing a coin. So what are the outcomes of tossing a coin? Getting head, tail, yes or no? And throwing a die, what are the outcomes? I'll get it 1, 2, 3, 4, 5, 6, right? See, I'm getting an exact number 1, 2, 3, 4, 5, 6, and when tossing a coin, my x is denoting how many number of heads I will get it. X is denoting the number of heads. So while tossing a coin, how many heads I'll get it? 1, right? So it is an exact number. X is taking an exact number, then which will be called as discrete random variable. Okay, right. So now let's see some of the properties for probability function. In the sense, when do we say a function is satisfies discrete random variable? So it should be satisfy two properties, right? One is probability should greater than or equal to 0 for all x. Okay. And the second property, sum of the probability is equal to 1. If it satisfies these two properties, if it satisfies these two properties, then p of x is called discrete random variable. Okay, now if it satisfies these two properties, then the p of x is called discrete random variable. Otherwise, if any property is not satisfied, then which will not be a discrete random variable. Okay, now which won't be satisfied the discrete random variable. Okay, right. Now, so let's see mean and variance of the discrete random variable. So what do you mean by mean? The mean value of the discrete random variable function is given by nu equal to summation pi into xi, and which can also denoted by e of x. Okay, this is the formula of mean of the discrete random variable. And let's see the definition of variance of discrete random variable, and which will be denoted by sigma square. Variance of the probability distribution of a random variable capital X is the mathematical expectation of x minus e of x whole square is summation pi into xi square minus nu square. See, this is the formula of variance of discrete random variable. Okay, right. So now we'll go to the first question in discrete random variable. Okay, right. See, once you read the question properly, then you can do the solution easily. Okay, and you can understand here what is mean by random variable. Okay, right. What is the first question? Let X denotes the number of heads in a single toss of two fair coins. Determine number 1 P of x less than 1, number 2 P of 0 less than x less than 2. Right? Did you understand the question? Here, let x denote the number of heads. What is mean by x here? X is taking the heads. X is taking the heads. Let x denotes the number of heads in a single toss of two fair kinds. Right? Okay. See, x is nothing but, you understand, right? Okay. Now my next question. I'm tossing two coins, right? So while tossing two coins, what are the possible outcomes? Tell me. Head head, head tail, tail head, and tail tail, right? These are the possible outcomes when tossing two coins. Yes or no? Right. Here here x denoting the number of heads. Yes or no? See, in this possible outcome, this is the first possible outcome, and this is second possible outcome, this is third possible outcome, and this is fourth possible outcome. Yes or no? See, in these possible outcomes, in the first possible outcome, how many heads I'm getting? Tell me. I'm getting two heads in the first possible outcome, right? Similarly, in the second possible outcome, how many heads I'm getting? One head. Yes or no? And in the third possible outcome, here also I'm getting one head. Now, coming to the fourth possible outcome, is I'm getting any heads here? No, right? So it is nothing but 0. See, these are called a random variable. These are called random variable. That's what I told you in the definition of random variable. X is a real valued function. X is a real valued function. It is not a variable. Okay now? Right. So these are the x values. Okay. Now I'm writing the probabilities of every random variable. Okay. Right. Let's see now. Okay. Right. 0 is nothing but 0 is nothing but I'm not getting head. How many times I'm not getting head in these possible outcomes? Only once, right? Out of 4 times. So can I say probability 1 by 4, 1 by 4, I'm not getting head. I'm not getting head only once out of 4 times, so that I can write it as 1 by 4. Similarly, I'm getting head once. Tell me how many times I'm getting head once? See, there are 2 times I'm getting head once. Yes or no? So can I say probability is 2 by 4? Because we know the probability definition, favorable outcomes by total number of outcomes. Yes or no? So that's what I'm saying here, 2 by 4. Okay. Right. Just a minute. 2 by 4. Now similarly, coming to the at x equal to 2. So what is nothing but these two? Getting number of heads 2. How many times I'm getting 2 heads? Only once, right? So can I say the probability 1 by 4? Yes or no? See, this is nothing but a discrete probability distribution. Okay, this is nothing but discrete probability distribution. Just a minute. So I'm taking, this is the table. right? Is it clear, everyone? How did I get the table? Let's talk again. Here I'm tossing two coins, right? I'm tossing two coins. Then what are the possible outcomes? Head head, head tail, tail head, tail tail. See, these are the possible outcomes, yes or no, right? So in this possible outcome, let's talk about the first possible outcome. How many heads I'm getting? Two heads. In the second possible outcome, I'm getting one head. And in the third possible outcome also I'm getting one head. Similarly, in the fourth possible outcome, I'm getting no heads. No heads in the sense, can I say 0 x? See, these are called random variables. So that's what here I denoted 0 1 2. Okay, 0 1 2. Now I'm writing probability of random variable. I'm writing the probability of every random variable at x equal to 0, at x equal to 1, at x equal to 2. See, what is mean by 0? Tell me. Not getting head. Yes or no? So how many times I'm not getting head? Only once. Yes or no? So in the sense, 1 by 4 means total possible outcomes how many? 4 gada. So 1 by 4. So similarly, getting one head. How many times I'm getting one head? Two times, right? So 2 out of 4 times. So 2 by 4. Getting two heads. See, in these possible outcomes, here only I'm getting two heads, right? So can I say 1 by 4? Yes. See, this is the table I framed by the given hint in the question. This table I framed by the hint in the question. What is the hint? Let x denotes the number of heads in a single toss of two fair coins. Okay, right, it's clear. So now I'm going to finding the first answer. Okay, what is the first question? P of x less than 1, it is equal to, right? We know, we studied actually what is x less than 1 means. What are the values of x here? What are the values of x? Only 0. See, we can denote as p of x equal to 0. Okay, because x is taking less than 1, right? Okay, so next, at x equal to 0, what is the probability I'm having in this table? Tell me. I'm having 1 by 4, right, at x equal to 0. So 1 by 4 is a solution of this p of x equal to 4. Okay now, right. So let's see the second answer. Right. So what is the second answer? Second question. P of 0 less than x less than, I'm just changing, x less than or equal to 2, it is equal to, right? So tell me, with this question, what are the values of x? What are the values of x? 0 less than x less than or equal to 2. So it is nothing but, can I say x values are 1 and 2? Yes or no? So I can denote here p of x equal to 1 plus p of x equal to 2. I can denote like this. Okay now, right. So next step. So at x equal to 1, what is the probability I'm having in the table? Tell me. At x equal to 1, 2 by 4, right? So that is the value for at x equal to 1, 2 by 4 plus. So x equal to 2. At x equal to 2, what is the probability I'm having in the table? 1 by 4, right? See, I'm writing here 1 by 4. Then by taking LCM as 4, new matrix will be added, right? So 3 by 4, this is my solution of the second answer, and this is the final solution of the given question. Is it clear, everyone? Right. So this is my first lecture of random variable. Now we'll see few more questions in the next lecture.